Okay, so before we get started in the next section, I wanted to talk a little bit about the software from this book here. This software is available um, on the Canvas. Let me move this over here for a second and I can show you the file name here. So it's the software for ODEs.jar. So I've downloaded this onto my computer, and when I ran it, this is the splash screen or the main screen that comes up, main menu. And we're not going to use a lot of this, but some of this is kind of handy. The DE Sketchpad is what I wanted to show you today, and the reason is because when you talk about curves in the plane, the problem with curves in the plane is that um, they're not functions, right? A lot of them aren't functions. So you can imagine a wild curve here going around the plane. That would be really hard to analyze in the XY plane. And so instead of analyzing that in the XY plane, what we're going to do instead is we're going to break the curve apart and we're going to analyze the components. And so you can see here in this curve, here's the y coordinate sketched out in time, and the x coordinate is down here. That's because it's graphed like this because it's more of a natural way of looking at the XY coordinate system, right? So the X and Y is going left and right as time progresses, and so that's why it's plotted this way, although normally you would see it plotted this way. In fact, let me go ahead and clear that. So normally you would see the X and Y coordinates both plotted uh, similarly like that. Okay, so here you see the X, this is X of t, and this is Y of t, and this is the plot of x of t and y of t together. So this is why we move to parametric equations when we start talking about curves in the plane for when we start talking about systems of differential equations. So you can see again here, right, that we can get pretty complicated in the xy plane, but then the curves in the x and y coordinates themselves aren't too bad. So do you remember, we've looked at these in calculus, do you remember what the graph looks like in the x and y if you split it apart? If you have a closed curve over here, whoops, let's see if I can get a closed curve. Closed curve, what does a closed curve mean? There we go. Closed curve will mean that what happens to this curve? This curve is going to start repeating itself over and over and over again, right? So closed curves in the xy plane correspond to periodic curves in the xy or x of t coordinate system and y of t coordinate system separately. Good. So that's something we might want to look for when we're looking at these. Similarly, we can do simple curves as well. We can just do straight lines, right? And we're going to be looking at straight lines when we look at some of our solutions. Okay, so this is again kind of a nice thing to look at if you're trying to remember how we dealt with parametric equations. So I would encourage you to take a look at the software. There's a lot of other things, whoops, going on here as well that we can look at later. For example, we have a pendulum here. We have something predator-prey is going to be interesting to look at. Okay, competing species will be interesting to look at. Okay, so for now, we're just going to use the DE Sketchpad. So if you can, I would encourage you to download this software and just experiment a little bit with it. Okay, so that leads us into a discussion of parametric equations, which will be next.